The unit circle is any circle with center at the origin and radius equal to 1. So this circle here is center the origin, and that length, that radius across there is 1, which means this point here is 1 on the x-axis, 1 on the y-axis, minus 1 on the x-axis, and minus 1 on the y-axis. Now, any point on this circle, any point P, satisfies a certain condition because we know that that length there is 1 because it is a radius. So for that point there, we have the x-coordinate going along here and the y-coordinate going up here. That's how we define that. And so for any point on that unit circle, we have that x squared plus y squared is equal to 1 by Pythagoras' theorem. That's a really important result. It's actually the equation of the unit circle, x squared plus y squared equals 1. But we're going to see how that is helpful in trigonometry very soon. But that's not the only way that we can define that point P. Yes, we can define it by its x-coordinate and its y-coordinate. That's perfectly valid. But there is another way to do this. The other way to define or describe P is to use an angle theta. So again, if we have our point P on here, instead of saying that it is x along and y up, we could say an angle measurement to get there, given that we know that the radius is 1. So given that we know that the radius is 1, we could describe an angle to get that. And we always describe the angle from the positive x-axis. So that would be our angle there, theta. It's always measured from the point 1, 0. Now, we also need to be a little bit careful here because I went that way. I could have gone down by theta. So we have to define our positive and negative directions here. We define this as being positive, so anti-clockwise. Is defined as positive. And clockwise, from that same point, is going to be defined as our negative direction. Finally, we have to name, or we don't have to, but it's useful to be able to name each of the bits of this graph. We split it into the 4 quadrants. And we label those quadrants as we reach them in the positive direction. So this one is quadrant 1, this one is quadrant 2, this one is quadrant 3, and finally, this one is quadrant 4. Now this gives us another way to define the position of any point. Because if we know that this length is 1 and we know the angle, that uniquely defines any point on this circle. Here, the angle is about 60 degrees or pi by 3. Over here, it would be about 150 degrees or 5 pi by 6. Down here, it's 270 degrees or 3 pi by 2 radians. And around here, it would be 330 degrees, or that would be 11 pi by 6 radians. So we can define any point on the unit circle using just the angle and the fact that this length here is 1.